In this video, I will explain the event loop in a rather simplified view.
My name is Syed Shah, and I'm the founder and CTO of 12 Tech.
If you build software using NodeJS, then it would be very beneficial to understand how it works under the hood. NodeJS architecture is based around the concept of the event loop. My purpose here is to provide enough underlying details to make you fully understand the concept in depth. However, still not go too deep to distract you with info which you don't actually need as an application developer. There are actually very good explanations of the event loop available on the internet. So if you want to dive even deeper, I have posted some of the links in the description and you can go and explore them. Okay, so before I go into the explanation of the event loop, I just want to set the perspective. I'm not also going to go into a comparison of Node's event-driven architecture with the traditional architecture, right? So once again, there's material out there that can be used. But a few points that I do want to mention is basically that Node is event-driven. The basic concept is that you register interest in an event, and then whenever that event happens, you get notified. The way you get notified is through callbacks in Node, which we all are familiar with. Also, this Node event loop is based on libuv. Libuv is the underlying library that actually implements Node.js event loop. Another important thing to note is it is single-threaded. The event loop itself is single-threaded. All of the user code should executes on a single thread, which is the thread that runs the event loop, right? So the simplified view of Node's event loop is as follows: is when the loop executes, the first step is to run the timers. Now, these are the timers that we set using set timeout and set interval calls. After that, there's some stuff that happens which I have eradicated in this view. And the next important thing that I want to touch is the heart of Node's event loop, which is polling for I/O. This is where we poll for the events that we are interested in. For example, incoming connection requests, data coming from our network calls, HTTP calls, for example, and also from files to do a file read operation, for example. And then there's some more stuff that happens, and then we check if the loop should continue, and then if it should be continued, then basically the loop starts over again. Another important aspect is callbacks. So for each phase has its own set of callbacks. So for example, for the run timers phase, if a timer has expired, then the corresponding callbacks for that timer would be called. And same goes for the polling state. So for example, when a connection request comes in, the corresponding callback for the connection request would be called. Same goes for any data that arrives from our network calls. Okay. Now, as far as this is the main general concept, and these are the phases that I want to cover. And going a little bit deep in how polling is done. Polling is done primarily on two types of IOs. One is network IO and the other is file IO. Okay. And what this shows is there is a direct connection with OS. So in the event loop, in the same thread, we will basically make a system call to perform the network IO, read or write. And the reason why there is a direct link is because we have a platform independent way in the underlying library to make non-blocking network calls for IO. Whereas in case of file IO, we have to use a thread pool. So the reason why I have to explain is because so that I can touch upon how the thread pool is used and where it fits in the picture. The problem with file IO is the library doesn't have a platform independent way to do non-blocking file IO, right? Because everything has to be non-blocking because this is just one single thread. So that's why for file IO and some of the other operations, we utilize the thread pool. The default size number of threads in the thread pool is 4, but we can adjust that. And besides file IO, other things that get executed by the threads in the thread pool is basically DNS resolution calls and user-specific code, which you can use underlying libuv's call to schedule your own custom code to run in a thread. To further understand the concept here, let's look at the sample code. So let's suppose we have this code in our main program, and we set a timeout for 1 second and then have this code. So first, when this code would get executed, the timeout would be set and the corresponding callback would be registered. Let's suppose the loop runs and the timeout expires. This would be detected in this phase, and then this callback would be invoked, this specific one. And then here we are making a call to get, and we have an await, which underlying is using promises. So this is a network call. For network call, sockets would be used. So we will make a network IO call, which would be non-blocking. And then the handle for this specific socket would be added to the list of events that we poll for. So here, somewhere here, when the callbacks are getting invoked, this call would be made, and then we would proceed to the next phase. Here we will start waiting on the events, and since this socket handle is now added in the list of events that we wait for, so we will wait for data on this socket. Let's suppose the data there, we get a response, and in that case, the call to poll would return, and then we would know that, okay, data for this socket has returned. We know that this is the implicit callback that we need to invoke when the call returns. So we would go ahead in this space, we will go ahead and execute this code. Okay. Now, another thing to note here is, which got certainly mentioned, but we cannot miss it because it's very important, is that the call to poll is actually blocking. And there are two ways that it returns. One is when data is available on one of the handles that we are polling for, or when a timeout expires. So internally, whenever a call to poll is made, a timeout is calculated. So if we don't receive any events during that timeout period, the call would return, and then we will proceed with the next phases of the event loop. Okay. So for example, for this call, data didn't come and the timeout expired. So, this call returned, we invoke callbacks, we may have had no callbacks to invoke for this specific iteration. We proceeded to next phases. And then, we started again, we polled for the same event again, and this time we received the data, and then we invoke the corresponding callback. So this is an example, a simple example of how this would function. Okay, so this is what I wanted to cover as far as the event loop is concerned. But if you want to dig further, now equipped with this knowledge, when you go and look at the resources that are available, they're gonna start making more sense. So for example, this is a snapshot of what we have on Node's official documentation. So, these are the phases of the event loop. So you have the timer phase, which we covered. We didn't cover this part, but I encourage you to actually now go and read up on these, and they're gonna make more sense now. Same goes for, if you look at the underlying library, which is libuv, I would encourage you to read up on that. That's gonna really help you understand this. But now with this knowledge, as I said, my hope is that it's going to make more sense and it's going to be easier to understand these further concepts now.